This is my week zero assignment. The course is regarding the transition metal organometallic chemistry principles to applications. So today I am going to discuss some basic problems regarding this transition metal organometallic chemistry for the week zero assignment. So we can start. Firstly, I will go to this basic problem of organometallic chemistry. There are four platinum plus two complexes, and my question is which among the platinum two complexes is the most thermally stable one? We are seeing that all these complexes has triphenyl phosphine, that is the ppH3 ligands anchored to the pt group, and the alkyl moieties are different. In the first case, we have a CH2 Me3 moiety. In the second case, we have an cyclometallated moiety. In the third case, is the acetylide moiety, and last case is the in-butyl moiety. So in all the cases, the platinum 2, all the complexes have 16 electrons because platinum 2 has 8 electrons, and from the two ligand centers, you are getting the four electrons, and from ppH2 you are getting 4 electrons, so total is counting to 16 electrons. In the first case, the beta hydride elimination is not possible because we have seen that there is no hydrogen in the beta carbon, so the first compound is little bit stable. But in the second case, the beta hydrogens are present, two beta hydrogens for the platinum atom. But since there is a ring strength, cyclometallated ring, that's why the elimination rate is comparatively lower. In the third case, the acetylide moiety has a beta hydrogen, but the platinum and the hydrogen that is pointing towards the anti direction or a trans direction. So that's why the beta hydride elimination is not possible, because you know that beta hydride and platinum, that is metal center, should come to the same plane, that is, they should be seen position to each other to initiate beta hydride elimination. In the last case, the n-butyl moiety, linear n-butyl moiety, that has the highest rate of beta elimination because all the hydrogen can comes to syn orientation to the metal atom, and beta hydrogen elimination is very smooth. That's why compound 4 is the most unstable one. So coming to the second problem, this is a problem regarding hapticity. Hapticity is nothing but the number of atoms that are connected to the metal center from the ligand. So the question is, the cycloheptatide, the C7H8 moiety in the complex MO C7H8 CO whole 3 is in, how much is, that's why how much that is the hapticity. But if we take into consideration the total valence electron of the case, the molybdenum has 6 electrons, and if we count the electrons from COs, there are 3 into 2, that is 6 electrons, so we have 12. And if it allows the 18 electron rule, then we can see that a C7H8 ligand varies the 6 electrons. So the C7H8 is a cyclopropylium cation moiety, where the 6 delocalized electrons are distributed among 7 carbon atoms, where all the carbons are sp2 hybridized. So that's why the hapticity of cyclopropylium cation is nothing but 7, and the number of electrons donated is 6. That's why this complex allows 18 electron rule. The third question is regarding the migratory insertion reaction that is quite common in organometallic complexes. The question is whether this complex MeMnCO5 reacts with 13CO or not, and what's the product. So if you have a look, the methyl group have 4 options of the cis CO carbons, and now it can undergo migratory insertions. So if the CH3 undergo migratory insertion, it can insert into the metal carbon bond, forming the MnCO CH3 moiety, and creates a vacant site in its place. Now if we inject 13CO, the 13CO gets bound to that vacant site, yielding the final product MECO MnCO whole 4 13CO. So the correct option is option 4. The last question is regarding which compound is not considered as the organometallic reagent. So options are cisplatin, ferrocene, Zeiss salt, and the Grignard reagent. So we know the Grignard reagent, there is a metal carbon bond, there's a metal is magnesium, and the Zeiss salt is the platinum bound with the ethylene moiety. It's also an organometallic compound. In ferrocene, we have an iron and we have 2 Cp moieties, so it's also an organometallic compound. But cisplatin is nothing but PTNH3O2 Cl2, where we know that there is no metal carbon bond present in cisplatin. That's why it's not considered as an organometallic compound. So the correct option is 1.